Hi, I'm Brent Shambaugh. I'm going to go over how I got involved with integrated space analytics and what I plan to do. This is the company that's digitizing the child of Ron Jones' 1989 Integrated Space Plan. As of note, my views do not necessarily reflect those of the company. Here's the top portion of Ron Jones' 1989 Integrated Space Plan. At the top, you see critical path, and then going down in time for the next 100 years of space development. This is linked to related side categories that allowed this to happen. In addition, I will suggest why I find underlying technologies such as linked data prudent for the company's effort. I will conclude with mention of some parties that I have been in touch with. If you are looking for a demonstration, see the one I gave at ISDC 2016. Between 9 and 10 years ago, I visited the Talk Polywell Forum for Nuclear Fusion. Not being a plasma physicist or electrical engineer, I wanted to know how what I learned in engineering school fit into Robert W. Broussard's polywell concept. I thought that the information in the forum and in my mind could be organized in a better way to aid understanding towards this aim. And I thought about a directed graph of relationships to model this. I have two graphs, one for a description of the things I know about polywell and one for a description of the things I know about chemical engineering. A semantic commonality between circles or nodes in the graph, or a shared URI for a node, represent an interlinking between the two graphs. Extending this interlinking between graphs to the integrated space plan, we can link to related projects such as Alpha CubeSat and Whitepaper Lunar Settlement Index. This is part of the Lunar Settlement Index data. This tells us through the contains link that lunar environment is part of the Lunar Settlement Index. We also see that lunar environment is related to 6 different roadblocks. Alpha CubeSat does not presently have a linked data representation of its activities, but if such a representation did exist, it might look like this. This is data structured in the pattern of a linked data platform standard-based solid server. A basic element in the linked data platform standard is a resource, of which a container is one of them. The ovals labeled Alpha CubeSat, Profile, Storage, Card, and Communication all represent containers. They are connected with LDP containers links. A particular container, storage, is related to the #me through the space storage link. This says #me has access to the stuff in storage. This may be data for the communication subcontainer, which may be for a social microblogging application, or it could be for a file storage location, or maybe other applications. A concept called EISPP, targeted at building distributed decentralized enterprises. EISPP is built on linked data and semantic web technologies. Unfortunately, these technologies as a whole suffer from not being very accessible to the layperson. For example, see Tim Berners-Lee's Semantic Web Layer Cake describing the components of the semantic web. In addition, challenges exist in approaching each individual linked data set. The underlying data structure which aid queries of a linked data set may not be known. This is remedied somewhat by the idea of linked data itself through follow-your-nose browsing. See, for example, a query of DBpedia for the resource Quiet Riot. This is an example of follow-your-nose browsing with LodLive. It allows you to click to follow related data sources. For LodLive browsing, the digitized integrated space plan can serve as one such starting point. You could start at the integrated space plan, all its underlying linked data, and then browse to other linked data resources on the web. In addition to linked data browsing, the literature suggests other entry points, such as a natural language query, federated SPARQL query, and a query using the underlying ontology structure for data. We'd also like to link the integrated space plan data to other data sets with linked data, such as the Whitepaper Lunar Settlement Index, the NASA spacecraft dataset, NASA facilities dataset, and DBpedia. There are also a number of data sources on the web for space that are not linked data that might be converted to linked data, including Space Manifest, Gunter's Space Page, more of NASA's data, and Celestrak for satellites. These could all be candidates for integration with the Integrated Space Plan. Of course, lessons from the past teach us that having linked data available on the web, may not support a flourishing business. Kasabi Flatbook, which was led by Thales, was shut down in 2012 after fears that the market was growing too slowly to be sustainable. Kasabi Factbook contained things such as the NASA spacecraft dataset and the CEA Warp Factbook dataset. One possible solution is to link the linked data to software that is being used to facilitate the construction of space hardware, so you would have data available about space in real time. This is the function of EISPP, where EISPP means Enterprise Information System for Peer Production. Peer production is defined by Wikipedia as a way of producing goods and services that rely on self-organizing communities of individuals. And in such communities, the labor of a large number of people is coordinated towards a shared outcome. So, yes, this could be individuals, but it might not just be peer production. It might be a bunch of existing organizations, such as universities and companies, and also the individual. But people who are doing space, and so here's a wireframe for EISPP with a car as hardware. So you have two different contributors for two different parts of a car. And this could be an example of what peer production would be. And so linking ISP data with enterprise data in EISPP targeted towards aerospace could produce an ecosystem where data evolves with projects related to the plant. The data could be hosted on linked data platform servers such as Solid, which allows for decentralized authorization and authentication of agents. So everybody wouldn't have to see your data, but you could expose parts of it, so you'd at least be able to integrate it. These servers could be linked to the core linked data platform server, which is hosted by the Integrated Space Plan. Linked data servers could be hosted by the party producing the aerospace project data. So, for example, your project data. In order for this linked data to be linked together, Integrated Space Analytics will host several core ontologies for space development. And these ontologies can be expanded over time to accommodate further use cases. And existing ontologies will be used or linked where possible. There are already a lot available for the web, so people will be familiar with the ontologies. And that's a lot better, it can be, than developing your own due to the learning curve. And interoperability of existing data. And here is a screenshot of the Integrated Space Plan ontology that we are developing. John Wilbanks in second generation open access, building on open content, presents an interesting problem he solves with semantic web technologies.
Modern science has gotten really complex. It's gotten very collaborative, interdisciplinary, technology driven. And some of the tasks that it's trying to solve appear to be so complex that no single organization can solve them.
I believe that ambitious goals like colonizing the solar system face challenges that are on the scale that John Wilbanks describes. It's open science, and the problem getting too big. Thus, his arguments of combining institutional efforts could support ISA's choice of linked data, a semantic web technology. In the space industry, there are many potential partners. One of these potential partners is the Waypaver Foundation. They have a lunar settlement index. It is organized into broad categories, and in each of these categories is a collection of roadblocks. And each of these roadblocks has a general solution, then a specific solution, and then for each specific solution there are certain current players. So here is an example for the roadblock category lunar environment, with the roadblock negative effects on life. So as we go down this graph, we see a current player of iSpace Technologies. So for this iSpace Technologies, we could say this is a linked data platform container, and then have some storage space for that, for their activities. So here's a screenshot with Warp, which is a browser for storage developed for Solid, which is a linked data platform compliant standard thing for building social applications that link data platform principles, which could be used with a waypaver under settlement index for the companies. So both the companies and waypaver could keep track of what they're doing so they know where to invest. Fortunately, I'm also acquainted with individuals that have familiarity with the auto regulations as they relate to space hardware. This person is Aaron Harper, Aerospace Maker. He's been participating in NASA's CubeQuest challenge. Also in the Open Source Hardware Association, they've been doing some calls, putting up some YouTube videos about how to look at communications with CubeSats. And he also knows a bit about ITAR regulations. So I believe he's one of the most promising individuals in the open source spaceflight community. Of course, there might be others, but he's an example. There's also this guy in India who's doing a Semantic MediaWiki for open source hardware. Well, it's not exactly space hardware. It does fall in the open source community, and I believe one effort should be to involve the open source community, because these are a lot of creative, motivated individuals which I believe are necessary, or historically have been necessary for furthering innovation. And I hope that this is a cutting edge way of looking at something. I'd like to point out that we're only at the tip of the iceberg for EISPP. There's a lot of other things that we can look at, such as value networks, looking at payments with respect to that, to really build kind of an economy around hardware, space hardware, whatever. I mean, there's going to be limitations with respect to ITAR, what we can do, how it will cross state, international boundaries, or whatnot, and what we really can collaborate. Fortunately, we have certain access controls that we can think about in terms of the design. And there's a lot of stuff to do. Again, looking at the way we could query this, the way we could connect to other things, how even the integrated space plane is going to look in terms of the data and its display. There's a lot of things to do.